Welcome back. Today we are going to be focusing on 2.3, well, technically it should have been 2.3c, Applications of Inequalities. So today's lesson we are focusing on our inequalities in the real world. So, Chloe and Charlie are taking a trip to the pet store to buy some things for their new puppy. They know that they need some food that costs $7 a bag, and they also want to buy some new toys for the puppy. They find a bargain barrel containing toys that cost $2 each. The first goal, just like with any word, just like any word problem, we want to write and model for this. So in order to get our model, we want to figure out our variables. Thankfully, they gave that to us. B for food and T for toys. To represent the amount of money that we want to spend, we know that food costs $7 for every one bag. So if I am buying multiple bags, we're going to multiply B by 7. We're going to add $2 for every toy. So that's 2 times T to represent the total cost of money. Together, Chloe and Charlie can spend no more than $40. Use this information and the expression you wrote in part A to write an inequality for finding the number of toys and bags of food they can buy. So to represent this as an inequality, we are going to focus on this phrase, spend no more than $40, right here. Spend no more. This is the important part. So 7B plus 2T, that represents the amount of money we can spend. Can we spend 40, like when we look at this problem, the question I like to ask myself is, can I spend exactly $40? According to the language, yes, I could spend exactly $40. Can I spend more than $40? No, I cannot spend more than $40. Can I spend less than $40? Yes. So that's why we're going to use less than or equal to 40 as my inequality. In part C, if Chloe and Charlie only buy one bag of food, solve the inequality and graph the solution on the number line below. So I'm going to solve this with 7 times 1. I'm going to put in B equals 1 into my inequality. And I don't know why I wrote equals here, but 7 times 1 plus 2 times T has to be less than or equal to 40. So 7 plus 2T less than or equal to 40. The only difference we're doing today versus what we've done the last couple days is now we are using inequalities to model a real life scenario. I can subtract 7 to both sides. 2T is less than or equal to 33. Divide both sides by 2, and T is less than or equal to 16.5. Well, here's the other difference. When we look at this, and come back down here, sorry about that. Explain what the graph of the solution means. Realistically, this is a word problem. Can I buy 0.5 of a toy? Not that I'm aware of. So that means realistically, the number of toys has to be less than or equal to 16. So we can put this on our number line. So we have 16. We'll put just a closed circle because they can buy 16, but they can't buy 17. And then we'll go to the left. So that is our inequality for a real life problem. Let's do a couple more examples. Valley Video charges $15 annual membership fee plus $3 for each movie rental. Tanya puts aside $100 for renting movies for the year. How many movies can Tanya rent from Valley Video? Again, we're going to use an inequality to solve this problem. The first thing I want to represent is how much money is being represented. So again, choose our variables. In this case, I have to pick my own. The one thing that's unknown is the number of movies. So I'm going to pick a variable that represents that. M is going to equal to number of movies. So for how much money Tanya can spend, she has to pay $15 up front, and then she pays $3 for every movie she rents. So so Tanya's budget for the year is $100. So again, just like before, I'm going to ask myself the questions. Can she spend $100? Yes, she can. Can she spend more than $100? No. So that means we have to be less than or equal to 100. And just like our other solving methods, we are going to undo the order of operations. So I'm going to subtract 15 of both sides. 3m has to be less than or equal to 85. Then I could divide both sides by 3. And m is going to be less than or equal to 28.3 repeated. And again, this is not realistic to say I can rent a third of a movie. So, real life answer, the maximum is 28 movies. So on a number line, I'm going to have 28 with a closed circle drawn to the left. You are a salesperson at Nissan. Each month you earn $2,200 plus 1/15 of your sales. You want to earn more than $4,000 this month. How much must you sell this month in order to earn more than $4,000? Once again, step one, we want to find our variable. We're answering the question, how much you must sell. So let's say S equals sales. And this is going to be in dollars. So your job, you earn $2,200 a month plus 1/15 of your sales. Your goal is to earn more than $4,000. So we need to use this to find out how much we are going to earn, how many sales we need to make. So we'll subtract 2,200 from both sides. 1/15 times S is going to be greater than 1,800. And now to undo this fraction, I'm going to multiply by its reciprocal to both sides. So S is going to be greater than 27,000. Is this realistic? Yes, it is. You need at least $27,000 in sales. So on a number line, I'm going to say, here's my 27,000. I'll put an open circle and off to the right. When we do our word problems, we need to make sure that we are answering them in context of the situation. So in our investigation, I'm going to leave the last couple ones for you. I want you to try them out and answer them as best as you can.